Before we get started today learning the new material, let's review how we could find our sine, cosine, and tangent of our special right triangles just using our triangles from geometry. So we know that a 30-degree angle, we could use our conversion to figure out that that's the same as pi over 6 radians. So if we're trying to find the sine, cosine, and tangent, we can just use our standard triangle we learned from geometry, where our short leg is going to be 1, our long leg is going to be the square root of 3, and our hypotenuse is going to be 2. And so then, if we're trying to find the sine of our 30-degree angle, it's just going to be 1/2. Our cosine is going to be the square root of 3 over 2. And then lastly, if we're looking at our tangent, it's going to be 1 over the square root of 3, which we will need to rationalize. Now, I want you to pause the video right now, and I want you to use the special right triangles from geometry to complete the 45 and the 60-degree angles. Remember, 45 degrees is the same thing as pi over 4 radians, and 60 degrees is the same thing as pi over 3. So hopefully you were able to draw your 45, 45, 90 with our relative lengths here from our geometry triangle. And then you could have used that existing 30, 60, 90 to find the sine, cosine, and tangent of 60 degrees. Now, remember, using SOHCAHTOA, we know what the sine, cosine, and tangent are. But there's actually, instead of just looking at tangent as being opposite over adjacent, there's another way that we can represent tangent. Tangent is also going to be the sine over the cosine. And let me show you why that's the case. We know that the sine is the opposite over the hypotenuse. So if we put that in like a big numerator, opposite over hypotenuse, and we know the cosine is the adjacent over the hypotenuse. And if you remember, if you're dividing by a fraction, you're actually going to invert and multiply. So we've got opposite over hypotenuse times the hypotenuse over adjacent. And when we do this, our hypotenuse ends up reducing out, and so you're just left with opposite over adjacent. And we know opposite over adjacent is just going to be the tangent. So this is another way of looking at the tangent. If you know the sine and cosine, you can figure out what the tangent is. And if you know sine, cosine, and tangent, you can figure out all of your reciprocal identities that we've learned earlier. Okay, so now we actually want to look at each individual triangle that we have here in our first quadrant. So if you remember, our first point right here around the unit circle is going to be at 30 degrees or at pi over 6 radians. And if we remember from our unit circle, by definition, the radius is 1 and it is centered at 0, 0. So I'm going to highlight this triangle right here that we're going to focus in on. And you can see that I've pulled this triangle out to the right-hand side. What ends up happening is that this angle right here is the 30-degree angle or pi over 6 radians. And you see I've got this drawn over here, over to the side. Now, in the unit circle, remember we said that the radius is 1. So here that I'm highlighting in blue actually is our radius of 1. So in our triangle, that is actually the hypotenuse. So let's use our relationship that we know in the special right triangle, in a 30, 60, 90 triangle, to figure out what the other missing sides are if we know that we have a radius of 1. So if we know we have a radius of 1, we know that the short side, we know the short side is going to be half of that. So the short side is just going to be 1/2. And we know the long leg is going to be the square root of 3 times the short leg, so it's just going to be the square root of 3 over 2. Now if we come back over to our unit circle, what this length right here corresponds to, that square root of 3 over 2, is actually the x-coordinate, square root of 3 over 2. And our height right here, that 1/2 right here, is our y-coordinate. So at 30 degrees, our x-coordinate is the square root of 3 over 2, and our y-coordinate is 1/2. So let's take a look. This is a little bit different triangle, but still will end up with our same trig ratios. So let's go through those. If we look at the sine of 30 degrees, we're looking at the opposite over the hypotenuse. So it's 1/2 over 1, which just gives you 1/2. If we look at the cosine of 30 degrees, it's going to be our adjacent over hypotenuse, which is the square root of 3 over 2 all over 1, which is just going to give you the square root of 3 over 2. And lastly, if we look at the tangent of 30 degrees, you could either put your sine over your cosine, or you could do your opposite over adjacent. So you've got 1/2 over the square root of 3 over 2, and you see that's still the same thing as the sine over the cosine. And remember, when you're dividing by a fraction, you're going to multiply by the reciprocal. So 2 over the square root of 3. And your 2's reduce out here, so you're left with 1 over the square root of 3 that you've got to rationalize. To give you the square root of 3 over 3 is our tangent of 30 degrees. And we should see that the sine, cosine, and tangent of 30 degrees using the triangle from our unit circle gives us the same values that we found using the triangle that we have learned from geometry. Now, what I want to point out to you here, we said that the coordinates of this point on the unit circle are at square root of 3 over 2, comma 1/2. And you notice here that the x value is the same thing as our cosine, and the y value is the same thing as our sine. So now we know that the x value here of this coordinate represents our cosine, and the y value represents our sine. So remember, before we had said if we are trying to find the tangent, we could just put the sine over the cosine. So if you know the coordinate, you could find the tangent. All right, let's go to our next point on our unit circle, or next angle on our unit circle. And this is right here at 45 degrees. I'm going to highlight my triangle here. We know this is at 45 degrees, or at pi over 4 radians. So 45 degrees or pi over 4 radians. And that means this angle right here is going to be 45 degrees or pi over 4 radians. And we know, again, our unit circle is centered at 0, 0. And we know our radius is 1. So looking at this triangle that's in red, and I know I'm highlighting in pink, but that is our radius of 1. And that corresponds to the hypotenuse on that right triangle. So we have a radius of 1. Or I'm just going to put radius equals 1. Now, if we wanted to find the lengths of these legs, we're going to take that 1 and we're going to divide it by the square root of 2. And we will have to rationalize that to give us the square root of 2 over 2. And in a 45, 45, 90, we know that both of the legs are congruent. So both of them are going to be radical 2 over 2. So if we take a look here, if we're trying to figure out what the sine of 45 degrees is, it's going to be opposite over hypotenuse, which is just going to give you square root of 2 over 2. And the cosine of 45 degrees is going to be the exact same thing, square root of 2 over 2. And then if we look at the tangent of 45 degrees, it's just going to be our opposite over adjacent, or you could do your sine over cosine, which is giving you square root of 2 over 2 all over square root of 2 over 2, and that's just going to simplify to 1. And if we go back up to the top and check our values for sine, cosine, and tangent versus what we had initially determined using our geometry triangle, you get the same results. So here we found, if we look at our triangle back on the unit circle, we see that this distance from 0 along the x-axis is the square root of 2 over 2. Sorry, I drew that a little bit too far. That square root of 2 over 2. And then this height right here is also going to be the square root of 2 over 2. So that means that those are our coordinates, square root of 2 over 2 and square root of 2 over 2. And remember, I had said earlier that the x-coordinate here is going to be your cosine, and your y-coordinate is going to be your sine. So now let's look at our last special right triangle, which is the 60-degree triangle. So we've got our last triangle here that's drawn. And what this means here, again, we're talking about the unit circle. We've got our center at the origin. We've got our radius at 1. So here's our radius on that triangle. That radius is 1. And we know our angle that I've just marked right there is going to be 60 degrees, or 60 degrees is also pi over 3 radians. Now you see that I've pulled my triangle out here, and again my hypotenuse here is going to be 1 because this is a unit circle. So using my properties of a 30, 60, 90 triangle, I know that the short leg is going to be 1/2 and the long leg is going to be the square root of 3 over 2. And we can look here back on our unit circle and know that this length right here is going to be 1/2, that short leg, and then that long leg is going to be the square root of 3 over 2. So we know here, again, this is at 60 degrees or pi over 3, and my coordinates here are going to be 1/2, comma, square root of 3 over 2. And remember, we had said that the x value of the coordinate is going to be your cosine, and the y value is going to be your sine. Now, what we haven't done so far is find our cosine, sine, and tangent using this unit circle triangle. So my sine of 60 degrees is just going to be opposite over hypotenuse. So that's going to be square root of 3 over 2. Our cosine of 60 degrees is just going to be 1/2. And our tangent of 60 degrees is going to be opposite over adjacent. So square root of 3 over 2 over 1/2. And remember, when you're dividing by a fraction, you're just going to multiply by the reciprocal. So that's going to be the square root of 3 over 2 times 2 over 1. And our 2's end up reducing out, so you just get the square root of 3 equals the tangent of 60 degrees. And we should end up seeing that our values of sine, cosine, and tangent all are the same as what we found up here in the beginning using our geometric triangle. Okay, so the last thing I want to do here before we pause on this screencast and move to the next one, I want to put it all together in the first quadrant. We know that in the unit circle, the radius is 1. We have just found all of our angles here, right? We found our, at pi over 6, at our 30-degree angle, we found our coordinates. We found our coordinates here at pi over 4 or 45 degrees. And lastly, found our coordinates here at 60 degrees or pi over 3. Remember that your x value is going to be the cosine and the y value is going to be the sine. Now, where this becomes helpful as well is at our quadrantal angles. Remember that our origin in the unit circle is at 0, 0, and our radius out here is 1. So when I come out here to my point on the circle at 0 degrees or 360 degrees, or you could think about this as 2 pi radians, that point is at 1, 0. And so up here at the top at 90 degrees or pi over 2, it's at 0, 1. Because again, your radius is 1, your radius in your unit circle. Okay, so what I'm going to do right now is stop this screencast and then we'll start another one with the rest of the notes.